this session, we'll do second problem in LCD. So let us consider one problem. Consider a linear constant coefficient difference equation described by the following equation. The equation is y of n minus 3 by 2 y of n minus 1 plus 1 by 2 y of n minus 2 is equal to x of n, and n greater than or equal to 0. Means there are no initial conditions. So what is asking? Determine impulse response and unit step response of the system. So how to solve this problem? The first one is asking if you apply delta of n, that is impulse, to the system which is described by LCD, so what is the output? And the second one is if you apply u of n as an input to this system, so what is the output? That is step response. So first step is we need to compute from the LCD, from the given LCD, we need to find out h of z. Once you know the h of z, so by using this formula we can compute y of z, h of z, x of z. We compute y of z for a particular x of z because h of z can be obtained by LCD. So first we need to find out h of z from the given difference equation, that is linear constant coefficient difference equation. So first of all, write the given equation, that is y of n minus 3 by 2. Apply z transform on both sides, right? What you will get? So z transform of y of n is y of z. What about z transform of y of n minus 1, that is z transform of y of 1 minus 1? You know that it is z power minus 1 into y of z. So I can write minus 3 by 2 y of z, z power minus 1 plus 1 by 2, what we have, z transform of y of n minus 2 is equal to z power minus 2 into y of z. So I'll write z power minus 2 into y of z is equal to z transform of x of n is x of z. Right. Take common y of z from this left hand side equation, that is y of z. You have 1 minus 3 by 2 z power minus 1 plus 1 by 2 z power minus 2 is equal to x of z. What we need? We need h of z, that is h of z is equal to, we need to write yz by x z. This is equal to 1 by 1 minus 3 by 2 z power minus 1 plus 1 by 2 z power minus 2. So this is the system transfer function which is obtained by using the linear constant coefficient difference equation. Now we need to find out impulse response for the given system. So what is it? Now we have h of z, apply delta of n for this, and what is y of n? This is called impulse response, right? Response for impulse input, right? How to find out this? From the standard method, we can write yz is equal to h of z into x of z. I'll continue here, right? So you can write yz is equal to h of z is already we obtained like this one, that I can write 1 by 1 minus 3 by 2 z power minus 1 plus 1 by 2 z power minus 2 into x of z, right? Here what is x of z? That is z transform of x of z is input is z transform of delta fn. You know that z transform of delta fn is 1. So what I can write now? My yz is equal to 1 by, because h of z will become 1. This is nothing but x of z is equal to z of delta n, z transform of delta n, that is 1. So x of z will become 1. Then have 1 minus 3 by 2 z power minus 1 plus 1 by 2 z power minus 2, right? Now you can find out y of n from this y of z by applying inverse z transform on both sides. Before applying inverse z transform on both sides, we'll simplify this expression to use the standard formulas. So how to simplify this? I'll write this y of z is equal to 1 by 1 minus, I'll write z power minus 1 minus 1 by 2 z power minus 1, that is minus 1 minus 1 by 2, that is minus 3 by 2 z power minus 1. I have written this term. Then the remaining is plus 1 by 2 z power minus 2, right? So for further simplification, yz is equal to 1 by, and what I will do is I'll assume this is one term, right? I'll write 1 minus z power minus 1, and from the remaining two terms, what I'll do is I'll take 1 by 2 z power minus 1 is common, and what are remaining terms? 1 by 2 z power minus 1, if you take common, I have 1, and this is plus, minus you are taking common means minus, and what we have 1 by 2 z power minus 1, remaining term is z power minus 1. So if you simplify this, yz is equal to 1 by, here you have 1 minus z power minus 1, 1 by z power minus 1. So I'll take common 1 minus z power minus 1 into what we have here. I have 1, and here if you take this term common, the remaining is 1 by 2 z power minus 1. We'll continue the next page, and I'll further simplify this expression. I'll assume this is equal to a by 1 minus z power minus 1 plus b by 1 minus 1 by 2 z power minus 1, right? And if you simplify this, you can get a and b. A is 2, and if you further from the simplification, you can get b 1. This I can write 1 minus 1 by 2 z power minus 1, right? This is equal to your yz. Now you apply, because you can use the standard formulas to convert into inverse z transform. Now you apply inverse z transform on both sides. So y of z inverse z transform is y of n is equal to, so here if you know the standard formulas, right, what we have, z transform, inverse z transform of 1 by 1 minus a z power minus 1 is, and here a is 1, so I can write 1 power n into u of n. And if you apply this formula for this, what is a here? This is a is equal to 1 by 2, so I can write 1 a is 1 by 2 from the formula power n into u of n, right? So this is equal to, what is this? Y of n equal to 2, 1 power n is 1, 2 u of n, and plus 1 by 2 whole power n u of n. So this is our impulse response. As we discussed, if you apply unit impulse to your system, the output is nothing but h of n, right? The second one is, in our problem, we need to compute step response, that is, if you apply v of n to our system h of z, so what is output? That is called step response. How to compute this? Once again we'll use standard formula yz is equal to h of z into x of z, right? So yz is equal to, we already obtained h of z. What is h of z from the previous discussion? That is 1 minus 1 by 2 z power minus 1 into 1 minus z power minus 1 into our x of z. So here what is x of z from this? X of z means this is nothing but z transform of u of n, right? So because x of n is u of n here, right? So what is z transform of u of n? That is equal to 1 by 1 minus z power minus 1. Now yz is equal to your h of z, that is 1 minus 1 by 2 z power minus 1 into 1 minus z power minus 1. And what is x of z? That is 1 by, that is into 1 minus z power minus 1. If you simplify further, yz is equal to 1 by 1 minus 1 by 2 whole power z power, sorry, this is 1 minus 1 by 2 z power minus 1 into these two terms 1 minus z power minus 1 whole square. To simplify this expression, to use the standard formulas, what we can write is use the partial fraction expansion method and simplify this. That I can use a by 1 minus 1 by 2 z power minus 1 plus b z inverse plus c by what we have 1 minus z power minus 1 whole square. If you simplify this, what you'll get is a is 1 by 1 minus 1 by 2 z power minus 1 c is 0 and the remaining 1 minus z power minus 1 whole square. Now this is my y of z. Now you apply z transform on both sides, inverse z transform on both sides. What you will get, I'll write it in the next page. You obtain this is 2z power minus 1 by 1 minus z power minus 1 whole square. Now if you apply inverse z transform on both sides, what you will get, y of z inverse z transform is y of n, and you know z transform of 1 by 1 minus 1 by 2 z power minus 1 is a is 1 by 2, so you can write 1 by 2 whole power n into u of n, and in the next term z transform of z inverse z transform of z power minus 1 by 1 minus z power minus 1 whole square from the standard formulas, you can write this is 2 into the inverse z transform of this part is, you can write n into u of n, right? So this is our step response. So what we have done here, first we have computed h of z, and from this we have computed output for the given impulse response, and the second one is we have computed y of n for the given u of n. So where we are assuming initial conditions are 0, that is n greater than or equal to 0 means initial conditions, means y minus 1, y minus 2 and all are zeros. The same way x minus 1, x minus 2 and all are equal to 0, right?